Right, we're back again with the crank, but since the last bit of video I spent half a day stripping the lathe down and realigning the headstock with the bed of the lathe. I was getting over 15mm distance on whatever I was machining. I was getting a 4/100ths run out taper. I've now corrected that to on 6 inches. I'm down to about 1/2 give or take 1/2 on 6 inches, which is better than 4/100ths on 15mm. So we've stripped the machine, done that, put it all back together again, and now I'm just going to bore the front of the crank shaft at 4.2mm. It says it's a 1032 UNF thread. I haven't got anything like that. I looked up on Google what the equivalent is and they say 5mm. So I'm going in with a 4.2mm drill to tap it to 5mm after. So it's going to be 12mm deep. So we'll see what happens. Bit of jungle juice on it. I invested in a set of drills that go from 1mm to 6mm in 0.01 increments. It was only a cheap set, but it's better than having no set at all. Yeah, it still pulls to one side when I lined it up, the tailstock. I still get this slight movement when I start drilling. It might be that the pilot hole was drilled before I realigned the headstock, so we'll see what the next one is like. That's pretty stable at the minute anyway. And we're getting two lines of chips coming out of the drill, so it must be cutting pretty equally both sides. And I've also put a Sharpie mark at 12mm on the drill so I can get the right depth. As long as the chips are coming out, I believe we're alright to keep going. So when they stop and start clogging up the drill, you've got to retract. And we've got about 2mm to go. And those cheap drills are not too bad. There we go. To depth. Look at that. Can't be bad for a cheap drill. Right. Find a tap and tap it. I'll just check the depth before I go any further, and I'll check that with highly technical way of checking depth. Yeah, we got just over, which will suit me fine. And then the next thing is to find our 5mm tap. Put that back in the box. I'll come back in a second when I found my 5mm tap. Right, we're back. We found them. Just check M5. I'll put the number 1 in first, and then I'll follow it by a plug tap to bottom it. Don't want to break anything, so gently does it. My tap doesn't appear to be fully tight in the jaw, in the chuck. There we go. Oh, I've done it up power good. How much have we got in there? We ask ourselves. Because we've only got a 9.7 of thread. Not that it makes any difference if we've got a bit more. So looking at that, we could be at the bottom. So change it for the bottoming tap. And we should get a few more threads this time. After we finish this, we've got a 2mm hole to drill in the relief that joins up with the hole from the back of the crankshaft, which feeds oil to the two bearings, or the front bearing. And then that'll be done in a milling machine. And the other thing we've got to do is cut the webs out on the balanced crank. I think that's gone as far as it wants to. I don't want to break the damn thing off, so out you come. There we go. When it starts to creak, it's time to stop. So that's the crankshaft so far. We can take it out of the lathe. And there we are. It has got the ball race on it. We've got the hole down the middle of the crankshaft from the rear, which is going to join up with the rebate there. We put a 2mm hole in there. We've got the 8mm diameter, we've got the 7mm diameter, we've got the 21.5mm diameter of the crank at the back, and we've now got the hole drilled and tapped. So next job, milling machine again.